Measures of central tendency. The objective of the video is to introduce to you to the different measures of central tendency, the properties of these measurements, and some examples of ungrouped data where we are going to look for the mean, median, and mode. So what is measures of central tendency? So this is a measurement where we try to um, describe a set of data through their central position in the distribution. Meaning, we try to make interpretations of the middlemost values in the data sets. How are these values gathered to the center of the distribution? And these measurements are what we call the mean, median, and mode. So in the distribution, these are the different types, the three main types of distribution. We have in the middle, we have the very symmetrical distribution, which is what we call as the normal distribution. And this is ideally what a measure of central tendency would be um, describing. In this case, we have mean, median, and mode that are found in the middle, meaning because majority of the distribution is in this part where the majority of the data are gathered here. So it's also ideal that we see our mean, median, and mode in this region, and that's under normal distribution. However, there are also instances where we have skewed distribution. We have negatively skewed and positively skewed. When we say negatively skewed, the tail of the distribution is point towards the left side. And for a positively skewed distribution, the tail is towards the right side. So notice how we compare mean, median, and mode in these types of distribution. So mean is less than, median is less than mode in negatively skewed distribution. And on positively skewed distribution, we have mean is greater than, median is greater than mode. And in usually if the distribution is skewed, that means there is a presence of outliers or extreme values in our distribution. In normal distribution, ideally we it has to be that it has we have to make sure that the distribution do not contain any outliers or extreme values. Before we proceed to some of the examples later, we should remember the general rounding rule that we don't, as much as we can, we don't round these numbers. We cannot go away with the fact that there will be instances where we need to actually present our values in decimal. And sometimes there are numbers with unlimited decimals. So to do that, ideally, we should not be presenting them into smaller decimal values. But if that cannot be, you cannot avoid it, then pwedeng gumamit ng at least 3 or 4 decimal places. The idea there is that we would like to have an answer that is very close to the expected value. Kasi the more na konti lang yung ating nilalagay na decimal places, the more na mag-vary yung answers in comparison to calculators, especially if you're performing manual calculations. So to avoid those discrepancy and in statistics, as little as 0.01 is interpreted, then we would like to have as much as possible very exact values. So manual calculation, we have to ensure that at least we represent our calculations in 3 to 4 decimal places and then do the rounding off to your desired number of decimals on the last step, not on the initial steps. So let's start with the first type of measures of central tendency, which is the mean. And in other term, we call it arithmetic average. And to do that, we have to add everything. So we have two ways to present mean. We can have the X bar, which is the symbol for the sample mean, and mu, or Greek letter mu, which is the symbol for the population mean. And we have the following properties for mean. Let's have mean is found by using all the values of the data, and it varies less than the median or mode. And then when samples are taken from the same population, and all three measures are computed for these samples, um, varies less, meaning there's not much of change in mean in comparison to median or mode, especially that mean is a unique value. And most likely, if we talk about statistics like variance, we really have to have the mean computed kasi part ng calculation ng variance is mean. And as I mentioned earlier, it is unique because we only have one mean in one distribution. We cannot have many more. Unlike mode and median sometimes may have, it's only one, but we should, there are instances when identifying median, you can have two numbers as in median and you still get the mean. So in most cases, si mean lang talaga yung nag-iisa lang talaga after the calculation. Mean is also cannot be computed when your distribution is open-ended. In other words, pwede pang dagdagan. It will really change. And it's not possible because part ng calculation ng ating mean is that we know the total number of data sets. And then, very highly affected by extreme values. So what do we call these extreme values? We also call them outliers, meaning if may distribution tayo na may 25, kunwari, in a class who took an examination and then our mean is 25, majority ng estudyante nakascore ng 25. If there are cases where 5, 6, or 7 ang score, masyadong malayo sa mean na 25, yung 5, 6, 7 na score na yan, ay tinatawag nating outliers. And if there are presence of outliers in our distribution, ma-change talaga yung value ng ating mean, and mean may not represent entirely what the distribution is about. As I mentioned din kanina, dun sa skewed distribution, baka hindi magandang basis for interpretation yung ating mean for skewed distribution. And usually, pag skewed yan siya, there will be outliers in the distribution. So example tayo ng calculation. Suppose we have the following data set. So what we do here is that we add everything, and n here is equal to 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 data sets. N is equal to 9. So we add everything. Tapos pag na-add mo na yan, you divide it by 9, all of it. So we have 276 divided by 9, and that's approximately 30.7. Notice here, yung 30.7, we can have more than 7. However, the rounding principle for mean is that we add one more decimal place in comparison to our raw data. So notice the data we have do not have any decimal values. Hence, our final answer will reflect one decimal value only. So to emphasize this, we have another example right here, not a very detailed calculation, but just for you to internalize what I've mentioned earlier. We have here a data where the decimal values, there are 2 decimal values in each number. So n is equal to 8 here because there are 8 data sets. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. You add everything. X is equal to 38.61. divided by 8, and approximately we have 4.826. Why do we have three decimal places in our final answer? Again, because there are two decimal places in our given. Now, what happens if there are varying numbers of decimals here? We may use we can make reference to the data set with the most which are most repeated in terms of number of decimals. So if there are more two decimal places here, then we can refer to uh, the data sets that have two decimal places because they are the majority in the distribution. But if that will not be enough, you may use um, you may refer to the number with the most number. You may refer to the value with the most um, decimal place. Weighted mean. This is a specialized version of a mean where certain values may incur weight. Formula is this: x bar sub w is equal to the summation of w times x all over summation of w, where w is equal to weight and x is equal to values. Best example for this is when we calculate for weighted average. So weighted average because our subjects, especially in college, it represents certain weight, and the weight there is your unit. So let's have an example where the subjects are the following, and these are the number of units per subject. So the weight of that subject depends on the number of units. So notice GE2 here is 6 units, meaning it's very heavy. It will affect most the final average. If you're aiming to have a higher average, then you should do well in GE2 because it is 6 units, followed by chemistry that is 5 units, and the rest is 3 units, and we also have 2. And this is our grade. Suppose um, this is what we would like to compute for our general weighted average. Then first, we have the column W here and column X. We multiply W and X together for our next column. So we have 7.5, 9.6, 8.1, 6.6, 13.0, 2.0 here as answers when we multiply column W to column X. And once you have multiplied that and you've got the product of W and X together, we add all W's and all WX. So the summation of W is 22, while the summation of WX is equal to 46.8. And then we substitute to the formula, so WX over W, or summation of each of these columns, we have 46.8 divided by 22. So approximately 2.13. This is the weighted average now. So even if you have a grade of 2.7, which is likely very low, and 2.5, which is also likely very low, you were able to stretch that out and 2.6. Hence, we have here 2 point something because these two grades have very heavy weight in comparison to the other subjects. The next type of measure of central tendency is the median, and this is the middlemost value in a data set, and it's not affected by extreme values. So if mean is very sensitive by outliers, median, on the other hand, is not affected by extreme values because, for one, again, median is found in the middle. Second, median is used when it is necessary to just see what's happening in the half of the distribution and the other half of the distribution, should you wish to compare half and half of each distribution. Then it's open-ended distribution. And since it's not restricted, it's fine to just have the median. Mean is very restricted because it's not open-ended, while median is open-ended. And finally, it does not react sensitively to outliers or extreme values. First, for instance, these are the um, numbers in your data set, and then we would like to look for the mean. So first instruction is that we arrange the numbers every time, either ascending or descending. So if you are to ask me, I'd prefer to use the ascending order because it's easier to, locate what follows next compared to starting from the largest number to towards the least number. Step 2 is that we select the middlemost value. So in the arrangement here, we get the middlemost value, which is 401. How so? It's easy. This is the only number we have 3 halves here and 3 also here. So this one is the remaining number. Hence, we have median that is equivalent to 401. And the entire example right here is because our distribution is odd, and likely because it's odd, we will have the median immediately without doing further calculations. Notice if our distribution is not odd. So 1, 7, 3, 2, 3, 4. There are 6 data in our distribution, and this is an even distribution. And should we wish to find the middlemost value, we're left with this region here, an empty region. Since we have 3 on both sides, we will add the 3 and 3 together and divided by 2 to get its median. It's just that it happens na ang median natin dito ay magkakapareho yung number. But there can be instances where this will be different numbers from each other, so you can expect a decimal value in your median. So in this case, we have 3 as our median. How about this? If these are your data set, what is the median? Possible it would be 201. So you have to arrange again the numbers before you identify your middlemost value. If you don't arrange them, you will not identify the middlemost values as well. Tornadoes in the United States, so these are the given values. Again, you arrange this in ascending order, or if you prefer the descending order, why not? And in this case, the middlemost value is 810. Why is it 810? The middlemost value, this is an even distribution, and since it's even, we get the average of the 2 middlemost values, and they result to 810. Next, the mode. The mode is the value that is often repeated in the distribution. And just like median, it's also not affected by extreme values. So what do we do by mode here? The properties of the mode are the following. So if you would like to see which is the most desired or most preferred, you would use mode. And it's easiest to compute because there's no computation really. You're just looking for the most repeated number. And it's used preferably for nominal or categorical data sets. Categorical meaning could be religious preference, gender, or political affiliation. Lastly, it's also not unique because there could be several modes in one distribution or may not have any mode in one distribution. So, but since you're just simply counting the numbers or the value that is most repeated, then it's not affected by extreme values or outliers. For instance, this one, notice that 5 is the most repeated value here. Hence, our mode is 5. So what number is the most repeated? Then that is automatically your mode. And since we only have one mode in our distribution, then that is called unimodal. Next, we have the following, and the repeating numbers are 10 and 13. Both are considered as the mode of this distribution because we have they are they are tied in terms of the how they are repeated in distribution. There are three tens and there are three thirteens, which means they are bimodal. But in cases where one of them has more value than the other, then only one mode exists. Kunwari, kung there are four tens in the distribution and only three thirteens in the distribution, then we don't have to say that it's bimodal. We automatically choose 10 because it has more number than 13. We only consider them bimodal if they are repeated in the same number. Just like this. There are three numbers repeated in the same manner. So 5, 7, and 8 are repeated twice. That means 5 and 7 are modes in the multimodal. The last example, on the other hand, is what we consider as no mode because there is no repeating number in the distribution. So that's also one of the risks in the calculations when you don't have the number of modes and there's no mode in the distribution. So we cannot just simply use mode in those times. So ideally, and the most preferred one is the mean. But if mean cannot be used, wag mong gagamitin din kung iyong distribution ay may outlier. So part ng checking mo na pag-identify mo ng iyong statistical tool is the presence of the outlier as well. Yes. That would be the end of the lecture on measures of central tendency. Thank you.